In this video, we're going to go ahead and solve a system of equations by graphing. So when we go ahead and graph these two equations, we're trying to look for where they intersect, and that's going to be our solution. So it's important for us to make note about what form our equation is in. So this is going to be in slope-intercept form, so y equals mx plus b. B meaning that's where we start, and our m is our slope, which is going to be how we move. So typically we use the phrase rise over run, with the top number telling us how we move vertically, how we rise up or down, and the bottom number how we move horizontally, left or right, or how we run. So in our first equation, we have a start of positive 4, which means that I'm going to go ahead and put my first point at positive 4. And then 1/3 is telling me that I rise up 1 and I go over 3. So I come up 1 and I go over 3. I'm going to put my second point, and that's enough information for me to go ahead and draw a line through that point, those 2 points. So I'm going to try to do my best that I can here. Kind of looks something like this. Now on iExcel, it's going to go ahead and lock in much easier than how I'm sort of messing with the line. Let's take a look at our second line. Our second line has a start of -3. So I'm going to go ahead and put my first point at -3. And I notice how I'm always going on the y-axis because that's where we start. This is our y-intercept. So we plot it on the y-axis. Take a look at your slope. We have the numbers 5 and 6, but since we have this negative out in front, rather than going up, that means I'm going to actually go down. So going down is negative and going to the left is negative. So we don't want to go left if we've already gone down. So we want to go down by 5 and we want to go over by 6, to the right 6. That's in the positive direction, which gives me that negative slope. So I come over here to my y-intercept. I go down 1, 2, 3, 4, 5 is how many I go down. And then I'm going to go over 6. 1, 2, 3, 4, 5, 6. I'm going to go ahead and put my point there, and I can draw my line now between those 2 points. Again, iExcel is going to lock in for us. But you can kind of see here on my iPad that the point that they're sort of coming together is at this -6 and 2. So the coordinate point, that coordinate point is going to happen at -6 and 2. That's the x coordinate, and that's the y coordinate. Remember, in our coordinate point, x always come first and then y. So my final answer, what I'm going to put into iExcel, is -6 and 2. Now some of you guys were asking, Mrs. Murphy, how in the heck do I do something when I have y equals, right? This is our slope-intercept form, y equals mx plus b. And what is this x minus 1? What does that tell me, right? That's in a different type of form. So let's go ahead, before I answer that second question, let's go ahead and plot our first question, our first equation, which is this 6x plus 4. This plus 4 means I start at 4, and 6, the number 6, notice how our previous problems are were fractions, so we were able to pretty clearly identify the rise and the run. This 6, if you're just given a number, is over 1. Any number can be put over 1. So my rise is 6, and my run is 1. So I start at 4. Ooh, look, I put my point at -4. That should have been at +4. So +4 because of the plus. So I have +4. I go up 6, all the way up 6, and I go over 1. There's going to be my second point. I'm going to go ahead and plot my line through those 2 points as best I can. Now, when I have the equation x equals -1, what that means is that every single point on that line has a coordinate point, an x coordinate point that is -1. So here's on the x-axis, you're going to look for -1. And so this point has the x coordinate -1 and 0. This point has -1 and 2. This point has -1 and 4. Really what we're doing is we're drawing a line that signals all of those values that live along this x equals -1 line. It's going to be a vertical line. So you can kind of imagine all of these points sort of like stacked up on each other, all of them having that x coordinate of -1. So x equals -1 is just a vertical line. So if this was x equals 5, then you'd have a vertical line at x equals 5, okay? It tells us where that vertical line is going to be. So now let's go ahead and take a look at where those two functions, or where these two equations intersect. They intersect here at -1 and -1. Both the x coordinate and the y coordinate are -1. So that would be my final answer that I would go ahead and submit. So if I'm given a set of equations where it's y equals 1, notice how my second equation is y equals 1. That means that we're going to look at our y-axis, and that's going to be any line that has the y coordinate 1. So this point has the y coordinate 1. This coordinate over here, I can choose any one I want, 6 and 1, right? So it's going to be all of these points that live on this horizontal line. So now we're looking at this horizontal line. Let me make that a little bit crisper, right? That's going to be a horizontal line at y equals 1. So if this was like y equals 5, then I'd have a horizontal line at y equals 5. So y equals are horizontal lines that indicate that every point along that line has a y coordinate of that value. In this case, 1, or in our second example, 5. Okay, so now that we kind of did the things backwards, we went ahead and we graphed y equals 1. Let's go ahead now and graph our top function, y equals -x minus 1. So y equals mx plus b. B is where I start, so I'm going to start at -1. And my slope is this negative. That negative is really a 1. Remember, any number can be put over 1. So my rise is -1 and my run is +1. Now, even though we use the word rise, we don't literally mean to go up all the time. It has to depend on whether that sign is positive or negative. So because it's negative, that means I actually fall down by 1, and then I'm going to go over to the right by 1. Remember, check yourself. If you plot that second point, it should match our slope, which mine does here, meaning that my slope is negative, so my line should be decreasing, right? This line should be decreasing because of that negative slope. Okay, let me go ahead and just make this a little bit clearer. There we go. So now let's take a look at where those two lines intersect. They intersect at -2, and the y coordinate is +1. Okay, so that's going to be my final answer that I submit to IXL. Last but not least, we identify these sets of equations as y equals mx plus b, right, in my second equation, but my first equation has the x and the y on the same side. So anytime you're given a linear equation with x and y on the same side, option 1 is to solve for y to get it into slope-intercept form. So by solving for y, I'm going to show you two options right now. Option 1, solve for y, which means that I'm going to go ahead and take this 2x and move it across the equal sign. So if that's a positive 2x, the opposite of a positive 2x is to subtract a 2x, leaving me with a -3y is equal to a -2x plus 12. You cannot combine these. This does not become 10 because that 12 does not have an x. So they're different terms, and that's why I do not combine them. My last step is going to be to go ahead and divide by this -3. Now, what I do to one side, I have to do to every single term on the other side. So I divide this term by -3, and I divide this term by -3, which gives me y equals this -2 divided by -3 is going to be 2/3 x minus, and then 12 divided by -3 is that -4. So now I have my slope-intercept form, y equals mx plus b. If you like to move terms around using your opposite operations, then use option 1. I personally like option 2. Option 2 is to find both the x and y intercept. So intercepts occur at zeros. So I'm going to switch back and forth. What does it mean when x is 0? what is that corresponding y value? So if I take x and I plug 0 in, this term is now gone, leaving me with negative 3y is equal to 12. Well, what times negative 3 gives me 12? Y would have to be negative 4. Negative 3 times negative 4 gives me that positive 12. So I know y is equal to negative 4. You've just found a coordinate of the equation 2x minus 3y equals 12. That coordinate is when you plugged in 0 for x, you got out a negative 4. So you can go ahead and plot that on your graph. Now, vice versa. Now I'm going to go ahead and plug it in, plug 0 into my equation when y is 0. So 2x minus 3 times 0 is equal to 12. Negative 3 times 0 is 0, so 2x is equal to 12. What times 2 gives me 12? 2 times 6 gives me 12, so x has to be 6. Again, you just found another coordinate point. When you plugged 0 in for y, you got an x value that was 6. So that's going to be where my second point is. You only need 2 points to go ahead and graph a line. So now that I have those 2 points, I can go ahead and draw a line through them. Now let's come back to option 1. Option 1 said we start at negative 4 because that's my y-intercept. So notice that that point lives right there, and I go up 2 over 3. Up 2 over 3. So you can see I'm getting the exact same line regardless if I do option 1 or option 2. I think my preference is to do option 2 because when I plug in zeros, that's going to immediately cancel out because anything times 0 is 0. So to me, I think the math is a little bit easier, but easy is relative, so use whichever method that you want. Now that I have my first equation graphed, I need to come and graph my second equation. So my second equation is going to start at positive 1, right? That's where my slope is, or my y-intercept. Start at positive 1, and my slope is 7/3. So that means I rise by 7 and I run by 3. So I go up 7, 1, 2, 3, 4, 5, 6, 7, over 3, 1, 2, 3. And I'm going to go ahead and graph a line. So it looks like I need to extend these down to figure out where they intersect. And it looks like they intersect here at the x value is negative 3 and the y value is negative 6. So what I'm going to put into IXL is negative 3 and negative 6. I think the trickiest part of this IXL is figuring out what kind of equation, right? Do I have slope-intercept form? Do I have standard form? Do I have a horizontal line? Do I have a vertical line? But the strategies may differ. The final answer is always going to be where those lines intersect. The end.